Hey everyone. In this particular video, we're going to be looking at the big ideas for section 5.4. So the first thing we want to look at is two-way tables and Venn diagrams. So when we look at two-way tables and Venn diagrams, this is a picture that we might want to see. So let's say we have event A, and then this is the complement to event A, which is not A. And then we have event B, and this is the complement to event B, which would be not B. And these numbers really don't matter right now. They just are what they are. 1, 2, 3, 4, just to get some numbers in there. So this is our two-way table. Now, how does a two-way table relate to a Venn diagram? And that's what we have right here. So if we draw some arrows, we can see that yes A and yes B, there's one person that's in that particular category, and that's the overlap, and that takes us to right there, okay, where this Venn diagram, the two circles overlap and they intersect with each other. That's what we've got right there. But if we look at A but not B, that's this 2 right here. Yes, A, but not B. That takes us to this spot. So when we look at this Venn diagram, this little half moon is yes, A, but not B. And then if we say yes to B and not C, that's right there. And then no to A and no to B. So not A and not B, or the complement to A and the complement to B is this 4, and that's outside of the two circles. So this is how two-way tables and Venn diagrams relate to each other. Now, there's some other rules that we want to look at as well. So let's look at the general addition rule for probability. And that formula looks like this. The probability of A or B is equal to the probability of A times the probability of B minus the probability of A and B. Now, there's one other symbol that we can use here. I'm going to pull this in. Let's use black. This is the same as the probability of A and then union B. And we actually talked about this symbol in the last Big Ideas video, but I wanted to put it in there as well. That doesn't look like a good parentheses. Let's make a better one. There we go. So the probability of A or B, this is the addition rule, is equal to the probability of A plus the probability of B minus the probability of A and B. Now you may say to yourself, wait a second, Mr. Mays. The last Big Idea video that we had in the last lesson, you told us that the probability of A or B was equal to the probability of A plus the probability of B. So these are contradicting each other. How can it be the probability of A plus the probability of B minus the probability of A and B, and at the same time be just the probability of A plus the probability of B? Well, it depends on whether or not A and B are mutually exclusive. So we know that if two events are mutually exclusive, that means they cannot happen at the same time. They cannot occur together. If A and B are mutually exclusive, then the probability of A and B is equal to 0. So this right here, if they were mutually exclusive, would be equal to 0. And therefore, we would just be left with the probability of A plus the probability of B. So this rule, this general addition rule, says the same thing, but we need to know whether or not event A and event B are mutually exclusive. If they are, let's just read this. If A and B are mutually exclusive, then the probability of A and B is 0 since they cannot occur together. Therefore, when A and B are mutually exclusive or disjoint, the probability of A or B is equal to the probability of A plus the probability of B. So if you're worried about getting these two mixed up, then just forget about this one on the bottom and just go with the one that's on the top. Because if you find that the probability of A and B is 0, then you're going to be right back to this formula anyways. One last thing I want to point out. This word right here, disjoint. Disjoint is a term that means mutually exclusive. So if you see the word disjoint, that also means mutually exclusive. In other words, the two events cannot occur together. So there's our big ideas for section 5.4. Hopefully this helps your understanding of probability, and hopefully you have a great day.